Sequence and series, arithmetic series. So in the previous class we were looking at an arithmetic sequence, which is a list of numbers in a particular pattern, such that the difference between each number is constant. So an arithmetic series is where we take that arithmetic sequence and we add all of the terms. So if you look over here to the right, you'll see our formula for sum to n terms. So S stands for sum, n is the position it holds, in other words, how many terms we're going to add together. A is, as before, our first term, and D is our common difference. So let's have a look at an example. We're given an arithmetic sequence . And the difference between a sequence and a series is that we will see the number being separated by a plus rather than a comma. So we have 1 plus 2 plus 3 plus 4. So clearly the sum of all of the natural numbers plus 79 plus 80. So in other words, we're getting the sum of all of the natural numbers up as far as 80. And it says find S80. So what that means is find the sum of the first 80 terms. Okay, so we start by calling it term 1, term 2, term 3, term 4. And therefore we can say A is 1 and D is the difference between the first and the second term, which is also 1, so 2 minus 1 is 1. And N is the position that our term holds, so 80 is N, so we're getting the sum of the first 80 terms. So we write down S of N is equal to N over 2 times 2A plus N minus 1 times D. So if I sub in my values, we have 80 over 2, 2 times 1, 80 minus 1 times 1, and therefore that gives me 40 times 2 plus 79. In other words, we have 40 times 81, which then gives me the sum to 8 terms, which is 3,240. So type 2, we have to find n. So here we're told find the sum of the arithmetic series. So again, told it's arithmetic. And we're given the arithmetic series as 11 plus 13 plus 15 plus ... all the way down to 51. So the difference between this example and the previous example is we don't know how many terms there are in this series. So I need to work out, let's get rid of all that. I need to work out what term is 51. So we start by writing down what's our first term. So our first term is T1, that's 11. Our common difference, because it's an arithmetic sequence, is term 2 minus term 1. So that's 13 minus 11, which is 2. And I know that the final term there is 51, but I don't know what n is. So if I go to my tables, and again, page 22, we can see that the general term for an arithmetic sequence is given by T of n is equal to A plus n minus 1 times D. And therefore, if that's 51 and A is 11 and D is 2, then I have a very simple linear equation to solve. which gives me 2n is equal to 51 minus 9. So 2n is equal to 42, and therefore n is equal to 21. So what that tells me is that there are 21 terms in this series. So if I want to find the sum of this series, then I write down S of n. So again, from page 22, is equal to n over 2 times 2a plus n minus 1 times d. I now know that n is 21, I know a is 11, and I know d is 2. So it's just a matter of subbing in to the equation. So we have 21 over 2 times 2 times a plus n minus 1 times d. So we have 21 over 2 times 22 plus 20 times 2, which is 40. So that gives me 21 times 2 times 62. And therefore that gives me 651. So if I add all of those 21 terms, I get 651. Okay, so let's look at one more example. So type 3 is where we're going to be finding an unknown using simultaneous equations. So here we're told that the fifth term in an arithmetic series is 14, and the sum of the first 6 terms is 57. And they want us to find the first term and the common difference. So it's arithmetic, so we write down T5, the fifth term, is 14. The sum of the first 6 terms is S6 is equal to 57. And we want A, the first term, and D, the common difference. So the fact that we're given the first term means that we need to go to our tables, again, page 22. We're going to be using our two formulas, our general rule and our general formula and our sum to n terms. So we write down T of n is equal to A plus n minus 1 times D. So if it's T15, that means that n is equal to 5. So we have 14 is equal to A plus 5 minus 1 times D. So we have A plus 4D equals 14 as our first equation. And then the second term, we're going to use S of n is equal to n over 2 times 2A plus n minus 1 times D. So therefore the sum to n terms, again in this case n is going to be 6. So we have 57 is equal to 6 over 2 times 2a plus n minus 1 times d. So we have 57 is equal to 3 times 2a plus 5d. So our second equation then is going to be 6a plus 15d is equal to 57. So that's our second equation. So now we have our simultaneous equations ready to go. So we might want to look at which one we're going to cancel, A or D. So I'm going to multiply the first one there by minus 6. So that will give us minus 6a minus 24d is equal to minus 84. And then we have 6a plus 15d is equal to 57. So minus 6a plus 6a is 0. And then we have minus 9d is equal to minus 18. And therefore d is equal to, sorry, that's minus 27, I should say. and therefore D is 3. So then if I sub D into 1, so I just go back there, so we have A plus 4D, so that's A plus 4 times 3 is equal to 14. So A is equal to 14 minus 12, so A is equal to 2. So we have our first term and we have our common difference. Okay, so what you're going to do for me now is you're going to go to page 208 in your books. And you're going to do question 1, part 1, part 3, and part 5. I'm going to do question 3 and question 4. I'm going to do question on the sheet then. So the sheet that says find n and s of n. At the very bottom of that page, you're going to do question 12, 13, and 14. On the sheet that says find a and d, so the simultaneous equations sheet, you're going to do 7 and 9.